Welcome to our YouTube channel, where we explore the cutting-edge world of technology and delve into the fascinating realm of quantum artificial intelligence, AI. In this video, we will embark on a journey to understand the fundamental differences between quantum AI and classical computers. Join us as we explore the potential of quantum computing and its implications for the future of AI. Understanding classical computers. Classical computers, as we know them today, have powered technological advancements for decades. These computers process information using bits, which represent binary values of either 0 or 1. The logic gates in classical computers manipulate these bits to perform calculations and execute instructions. However, classical computers face limitations when it comes to solving complex problems efficiently. As problems scale, the time taken to solve them grows exponentially, known as the exponential wall. Enter quantum computing. Quantum computing harnesses the principles of quantum mechanics to process information in a radically different way. Instead of bits, quantum computers utilize quantum bits, or qubits, which can represent multiple states simultaneously thanks to a phenomenon known as superposition. This property allows quantum computers to perform parallel computations, exponentially increasing their computational power. Furthermore, qubits can also be entangled, enabling the creation of complex interconnected systems. Quantum AI and its potential. The fusion of quantum computing and AI opens up unprecedented opportunities. Quantum AI combines the computational prowess of quantum computers with the learning and decision-making capabilities of AI algorithms. This combination holds immense promise for applications such as optimization problems, machine learning, drug discovery, and cryptography. Quantum AI has the potential to solve complex problems exponentially faster than classical computers, revolutionizing industries and driving scientific breakthroughs. Challenges on the path. Despite its immense potential, quantum AI faces significant hurdles. Building and stabilizing qubits to maintain coherence, minimizing errors caused by decoherence, and managing noise are among the key challenges. Quantum algorithms must also be developed and refined to fully exploit the power of quantum computing. Moreover, the resources required for building and operating quantum computers are currently limited, making them inaccessible to many. The coexistence of classical and quantum computing. While quantum AI shows great promise, classical computers still play a vital role in our technological landscape. For many everyday tasks, classical computers remain more than sufficient and cost-effective. Moreover, classical computers continue to advance, incorporating AI algorithms that enhance their capabilities. Therefore, a future where classical and quantum computers coexist is likely, with each serving different purposes and complementing one another's strengths. In conclusion, quantum AI represents a new frontier in computing that has the potential to revolutionize various industries. While classical computers continue to dominate everyday computing tasks, the advent of quantum computing brings forth new possibilities. As we witness further advancements and breakthroughs, it is an exciting time to explore the realm of quantum AI and its implications for our future. Remember to like this video, subscribe to our channel, and leave your thoughts in the comments section below. Stay tuned for more exciting content on technology and innovation.